So we want to solve this inequality. Okay, so first of all, make sure that this you know that this is an inequality, so we cannot just multiply by x minus 1 and x minus 2 on both sides, because we know that if we multiply with a negative number, then the sign of the inequality changes, and we don't know whether x minus 1 is positive or negative. That's why we cannot just multiply with x minus 1 or x minus 2 on both sides. So we have to bring all these values with involving x on one side. Okay, so we can write the given inequality like this. Since this is positive, so if you bring it here, it will become minus x minus 2 divided by x minus 1, and the sign of the inequality stays the same. Okay, so the next thing is to cross multiply. In other words, we could call it as taking as LCM. So we have on the denominator we have x minus 2, and here we have x minus 1, and on the top we had here x minus 1. So we have x minus 2 here, so we will multiply with x minus 1 here. It is sort of cross multiplying. Then we will get we will have x minus 1 to the power 2, because x minus 1 is here, and if we multiply it with itself, then we get its second power. Secondly, we will get here x minus 2 to the second power, and the sign of the inequality will stay same. Okay, and we know now the formula. So we know this formula, a minus b to the whole square is a square plus b square minus 2ab. So let's use this formula. So if we use this formula, then here we will get x square plus the second term is 1 square is just 1, minus 2 times first term and the second term, product of first and second, which is just 2x, minus same here, but we will have on parenthesis here because here we have a negative sign. So similarly, first term square plus square of the second term minus 2 times first term and the second term, so we can write it as 4x whole divided by, we have not done anything in the denominator, so we can just write it as denominator as it is, and the sign of the inequality is same. Okay, now we have to FOIL this thing, the negative sign, with all these terms inside the parenthesis, so we can just write this guy as it is, x square plus 1 minus 2x minus, if you FOIL minus with x square, you will get minus x square, then minus 4, and now you have to switch the signs, so negative will become positive 4x, and the denominator will stay same. Okay, so we can now cross out these things. So we have 4x minus 2x, so this is equal to 2x, and then minus 4 plus 1 is minus 3 divided by x minus 2 and x minus 1 less than or equal to 0. Okay, so I need values of x letters, so I will just isolate isolate x, so I can take out 2 common, so I can just write as x minus 3 over 2 divided by x minus 2 and x minus 1. Since 2 is a positive number, so you can divide by 2 on both sides to get rid of this 2, and we will get x minus 3 over 2 is just 1/5 divided by x minus 2, and we have x minus 1 less than or equal to any number multiplied by 0 is just 0. So the given inequality is equal to this one. Now we will solve this inequality. Okay, if we somehow solve this inequality, it means that we get the solution of our inequality. Okay, so let me rewrite this inequality again, the one we just got. So this was x minus 1 to the 5 1.5 divided by x minus 2 x minus 1 less than or equal to 0. Okay, from numerator, now we need to find the zeros of numerator and denominator. On the numerator, we have x minus 1, so we have to set x minus 1.5, set that equal to 0. And on the denominator, we have two terms, the product of two terms, x minus 1, x minus 2, set the product equal to 0. Okay, so just after some algebra on the first term here, we can get the value of x, that is x is equal to 1.5. Okay, and after now we have product of two terms, and the product of two things is equal to 0. It means that one of them is at least equal to 0, so we can set both equal to 0, x minus 1 equal to 0, and similarly just add 2 on both sides, so you will get x equal to 2 from first equation, and if we add 1 on both sides, then we will get x equal to 1 from the second equation. So these are the zeros, in other words, these are the boundary values, so we need to plot them. So how can we plot the boundary values? So we have a number line from negative infinity to infinity. Okay, so one thing you need to know, that for the values on the denominator, you need to plot them with dotted values, dotted line. And I will tell you in a moment what does that mean and why we need a dotted line there. So we had 1 and 2 and 1.5. The smallest value among these three is 1. So I will use a dotted line here. X is equal to 1. Oh, sorry, dotted line. I mean the dotted line. So this is a dotted line. And then we have x equal to 1.5. So for numerator values, we need to have bold line. (1.5). Then here we have to write with a dotted line. We have to label this value with a dotted line. So with a dotted line, x is equal to 2. These are the boundary values. So we got 4 regions, 1, 2, 3, and 4. And now we can pick any value. So these values are called test values. So we can pick any test value from negative infinity to 1. And so I think 0 is the most easy to work. That's why I'm picking 0 here. And any value from 1 to 1.5. So I would like to pick 1.4. Again, it's up to you. Any value between 1 and 1.5 will work. Any value between 1.5 and 2. So 1.6 could work, and any value from 2 to infinity, so we can pick 3. So now we have to check these test values. So the first test value is x is equal to 0, and I need to plug in into the final equation. Okay, so we don't need to simplify. Okay, x is equal to, plug in x equal to the test value 0 minus 1.5 divided by 0 minus 2 and 0 minus 1. Okay, we don't need calculator, we don't need precise answers. The only thing we need are the signs. 0 minus 1, 0 minus 1 is negative 1.5, 0 minus 1.5, sorry, 0 minus 1.5 is negative 1.5. The only thing we need is the sign, which is negative on the top, and on the bottom 0 minus 2 is negative 2, so the negative sign here, and 0 minus 1 is negative again, so the negative sign here. Okay, now count the number of negatives. The pairs will cancel, so this negative will cancel with this one, so we got one extra negative, so we have a negative sign here. In other words, if we have an odd number of odd number of negatives, that is negative, so just write it negative on this region. The second test value is not 1 but it's 1.5. That's why I have with arrows, these test values I denoted them with arrows, and these lines are slightly bigger than the previous lines. The second one is x equal to 1.4. Okay, again you need to plug in here. X is 1.4 minus 1.5 divided by x is 1.4 minus 2. X is 1.4 minus 1. 1.4 is less than 1.5, so the sign with 1.5 is negative, so we have negative again on the top. 1.4 minus 2 is negative, and 1.4 minus 1 is positive. So now we have two negatives, they will cross each other and we will get a positive answer. So the second region right here is the positive. Okay, next test value is 1.6. X equal to 1.6. Okay, plug in x equal to 1.6. 1.6 minus 1.5 divided by 1.6 minus 2. 1.6 minus 1. 1.6 minus 1.5. 1.6 is bigger than 1.5. We have a positive sign. 1.6 is less than 2, so we have a negative sign. 1.6 is greater than 1, so we have a positive sign. And we have one negative, so that means we will have a negative answer here. The only thing we need is the sign. We don't need the exact value, and the sign matters for us here. Last test value is 3. X equal to 3. So let's plug in x equal to 3 here. 3 minus 1.5 divided by 3 minus 2 and 3 minus 1. 3 minus 1.5 is positive, divided by 3 minus 2 is positive, times 3 minus 2 is positive. So we don't have any negative value. Positive times positives are always positive, so we will get a positive answer here. So in this final region we have positive answer. Okay, now if you look at this final inequality, then this says less than or equal to 0. Less than or equal to 0 means negative. So the regions where our test value gave us negative are our answers, and these are not our answers. So our answers are okay. So how can we write our now the solution set? How can we write our solution set? Okay, so we will start from negative infinity, and then we need to go up to 1. Okay, now these solid lines and dotted lines are important, since this is a dotted line and we denote the dotted lines with the open parentheses, and infinities are always and we use this open parenthesis with infinities, because this parenthesis means the end value is not included. The reason is, if you plug in x equal to 1, anything divided by 1 minus 1, 0, anything divided by 0 is undefined. That's why we don't want x to be 1, and we cannot have x equal to negative infinity or infinity. That's why with infinity and minus infinity we will have always parentheses like this. And then we don't have any value in this region in our solution, so the next interval is from 1.5, because this interval contains these set of values from, sorry, not until here, from here to here, and the first was from here to here. So we will say union, and now you can guess this is a solid line, so we will have a bracket here, and then up to, it goes up to 2, and at 2 we'll have again an open parenthesis. So this is our answer.